circuit theory. You listen the circuit theory, you don't feel phobia like this. Circuit theory is very tough, it is a problematic. Don't feel. First of all, circuit theory is very important. It is the backbone of the ECE students. It is the backbone of the ECE students. Very mathematical subject. It is the very easiest and simple problems will be there. It is the very easiest and very simple when you are go through it, when you listen the first of all. Okay, so you are scoring the 15 marks. You are scoring the 15 marks. It is a very basic subject. It is the very basic subject. Whereas in diploma you study the BEEE and networks theory. So in the circuit theory, I am explaining the topic transmission line. Transmission lines. What is the transmission line? Transmission line is the wire. Transmission line is the wire which is transfer the electric signal or electromagnetic waves from one point to another, or transmitted to receiver, electric or electromagnetic. So electric or electromagnetic. So this, in another words, it is convert the electrical to electromagnetic. Okay, so these are these transmission line transfer the signal. So it is also called the good impedance matching device. It is also called the good impedance matching device. It is also called the good impedance matching device. Next, it is also called the resonant circuit. It is also called the capacitor, inductor, so now what is the equivalent circuit of this one? Resistor, inductor, this one. Otherwise simply you do not like this. Now the transmission line mainly used for the purpose of transmit the electric and electromagnetic signal from one point to another point. The primary parameters. So in this circuit, this is the simple RLC network. It is a simple RLC networks. In this network, mainly the parameters are primary parameters are RLCG, and secondary parameter. Secondary parameters are propagation constant, characteristic impedance. These are the parameters. Now, what are the different types of transmission lines? Open wide transmission line, parallel transmission line. Next, waveguide, coaxial cable, optical, fiber optical cable. These are the open wire, parallel wire, coaxial cable, waveguide, fiber optical cable. These are the different types of transmission lines. Sir, so transmit the signal, no? So it is transmit the signal to load from transmitter to receiver. It is transmit the signal. Transmit the signal. While it is transmit the signal, so what is the main requirement is what? You are transfer the signal from one point to another point. While you are transmitting, what you are expecting output side, you are completely 100% you transfer the signal from the source. So 100% you transfer the signal from the source means what? Nothing will be nothing will be go back. Okay, so some part of the signal, if it will be return back, it lost the signal. What we call it is, you lost the signal. You lost the signal. So that is called the reflections. That is due to the reflections from the load. So this is called the mismatching. What we call this is called the mismatching. Mismatching. Now this is called the mismatching. Now the transmission line is Z0. This Z0 is the input impedance. Z0 and the ZL both are equal. Then it is called the good impedance matching. So there is low losses, lossless, not low loss, lossless. Okay, Z0 not equal to ZL. There will be losses will be there. Losses are present. Okay. Now these all parameters are in terms of other parameters. What are the secondary parameters? We are discussing these. No. Now first of all, what the secondary parameter is what? Propagation constant, and another is the characteristic impedance. Characteristic impedance I am denoted by the ZCH, propagation constant and characteristic impedance. Propagation constant in terms of primary parameters, it is derived like this: R plus J omega L into R G plus J omega C, and characteristic impedance is R plus J omega L by G plus J omega C. G plus J omega C. This is the characteristic impedance. Okay. Now suppose the transmission line is infinite length. The transmission line is infinite length. So what is the characteristic impedance of the transmission line? What is the characteristic? What is the characteristic impedance? What is the load impedance of the load impedance? What is the impedance of the input impedance of the infinite transmission line? Input impedance is equal to characteristic impedance of the transmission line. When the Z0 and ZL both are equal, it is matching. So Z0 and ZL both are equal. It is what we call it is good impedance matching. Okay, so Z0 is equal to characteristic. When it is input impedance equal to characteristic impedance, the transmission line is infinite length. Okay, so when the Z0 equal to when the transmission line is finite, it's finite and terminated by the characteristic impedance. Then the input impedance Z0 is also characteristic impedance. Reflection coefficient. When you are transmit the signal, some part of the signal is reflected due to mismatching of impedance. Input impedance and the load impedance are mismatches. Some reflections will be generated. So due to the reflections, what will happen? The signal will be losses. Okay, so this will be, you are measured in terms of we are measured like a reflection coefficient. So what is the reflection coefficient? The reflected signal by incident signal. Incident wave. Incident signal and reflections by incident wave. Reflected wave by incident wave. In terms of voltage or in terms of current? In terms of voltage or in terms of current? Okay. In terms of impedance, ZL minus Zin or Z0. ZL minus Zin or Z0. It is the input impedance, nothing but. Load impedance, input impedance, load impedance, input impedance. Okay. The reflection coefficient. Reflection coefficient is 0. When it is 0, ZL and Z0 is input and output impedance both will be same. The reflection coefficients are 0. Means what? Perfectly matched. Reflection coefficient will be 0. Reflection coefficient will be 0. So no losses will be there. The reflection coefficient is -1. When will it be -1? Short circuited. Means what? ZL is equal to 0. Means short circuited. Reflection coefficient is +1. Open circuit. Open circuit means what? That ZL is equal to infinite. Okay. This is the reflection coefficient. Reflection coefficient. So the incident wave is, you are assuming this one. So this is the traveling wave. So it is some reflections are denoted by the another wave. This is the reflected wave. So this is the traveling wave and reflected wave. So the reflected wave is combined with the traveling wave. It is from the standing wave like this. Combination of reflected and reflected and incident wave is called the standing wave. Standing wave. Standing wave. So in this standing wave, this we call the, suppose take the voltage in terms of voltage. This is the Vmax. This is the Vmin. Or in terms of current, Imax and Imin. So this is denoted by voltage standing wave ratio. It is Vmax by Vmin. Vmax by Vmin. Okay. So Vmax by Vmin. Vmax by Vmin. So this is in terms of reflection coefficient, VSWR. VSWR in terms of reflection coefficient, 1 plus reflection coefficient by 1 minus reflection coefficient. Okay. Modulus we are taking. Okay. Now VSWR is equal to, and reflection coefficient 0, 1. When reflection coefficient is 0. VSWR is equal to infinite when reflection coefficient is less or minus 1. Okay. So when we call the circuit is very good, VSWR is 1 or reflection coefficient is 0. Okay. What is the range of reflection coefficient? -1, 0, -1 to 1. -1 to 1. VSWR 1 to infinite. So what is the, okay, in terms of, we are talking the parameters, losses are measured in terms of reflection and VSWR parameters. We are measuring parameters are reflection coefficient and VSWR measuring parameters. Okay. Now how you avoid this one? It is the circuit is means of what is the changes will be made while the distortions will be occurring in the network. The network is the combination of the RLC network. So what modification will be taken while losses will be occurring? You are measure the loss. So this loss will be avoided how? Totally the circuit will be removed or small modification will be done. How will we are done these all things? Okay. So for distortionless transmission line. What is the condition for distortionless transmission line? Lg is equal to Rc. This is the condition for the distortionless transmission line. Okay, so there will be no distortion for in the transmission means you follow this condition. So what the inductance and the conductance product should be equal to the resistance and capacitance. This is the condition for the distortionless transmission line. Okay, this is the condition. Okay, so then what is the characteristic impedance? Root of L by C. Okay, this is the condition. And the next, what is the velocity and propagation velocity? Propagation means what? The wave will be travel with which with what velocity? It is 1 by root LC. This is the velocity. Okay, the circuit will be already designed, but losses will be occurred. So how we are avoiding? One more technique. This is the technique. This is the while we are designing the circuit, you take this condition, you follow this condition. But after design, you are then also you are getting the losses. So what will we take the measurements? Take the stub. This is the stub. This is a stub. This is the short circuited single stub. Okay, so what it is means? It is avoid the radiation loss. What is the purpose of stub? It avoid the radiation. How? So this length will be important. This length and this length you are adjusting. What will be happening from this point and from this point? Whatever reflections you are getting, VR1, VR2. Okay, so this magnitude and this magnitude and this phase, magnitudes are same and phase inverse. Okay, this is 90, this is minus 90 phase. Okay, both will be cancelled. These two reflections will be cancelled. Okay, then zero reflections will be occurring. Zero reflections means what? No losses. Okay, that for that purpose we are using the stubs. Double stub. Double stub is more advanced. Advanced means what? More accurate results. Okay, double stub. Next, open stub. Open stub is for it is purpose of radiator. It is one application. Okay. Next, quarter wave. The wavelength, the length of the transmission line is quarter wave. Suppose quarter wave. Quarter wave is a good. It is short circuited quarter wave is acts as the resistive transmission line. Short circuited quarter wave less than the quarter wave short circuit is acts as the inductor. Open circuit less than the quarter wave acts as the inductor, capacitor. Okay, like these applications are there. Okay, conditions based on the condition, different types of transmission lines are there. From this maximum 5 bits will be expecting this topic. From this topic 5 marks compulsory will get. This is further, it is very useful.